everyone, I am Dr. Gayathri NS, working as Assistant Professor of Chemistry in SNS College of Engineering. Today, we are going to see IR spectroscopy, its principle, working and applications of IR. Now, Gayathri will explain the principles and definitions of IR spectroscopy.
Hello everyone, now we see the topic IR spectroscopy. IR spectroscopy is an important anatomical technique for determining both organic and inorganic technique. It is also called vibrational technique. It lies the wavelength 0.7 to 400 millimeter. It has two types. Electromagnetic spectrத்தில் வந்து longer wavelength ஆகவும் lower frequency ஆகவும் இருக்கு. Now we can see the principle. Near IR spectroscopy near 12,500 to 4,000 centimeter per IR spectroscopy 4,000 to 600 centimeter per fair IR 670 to 500 centimeter per. There are two types of vibration. One is stretching, another one is bending. Stretching have two types. One is symmetric, another one is asymmetric. Symmetric has 2 bond length half increase, asymmetric has 1 bond length increase, another bond is decrease. Next is bending. Bending have two types. One is in-plane bending, another one is out-plane bending. Next topic is overcome with Abhinaya.
We are going to discuss about working principle of IR spectrophotometer. This is the block diagram of IR spectrophotometer. The basic components of spectrophotometer is, first of all, the source. The most of the common sources used is nernst glober and glober. Nernst glober is a tube-like structure. It's made up of scorium, thorium and yttrium. Glober is made up of, it is look like a cylindrical rod made up of silicon carbonate. Next one, the sample cells and sampling techniques. Sample cells are made up of NaCl. It is transparent to IR light. In gaseous sample are taken in 10 cm long and liquid samples are taken in placed between the two discs of NaCl, and solid samples are taken in a fully grinding or mineral oil or KPR palette. It should be transparent to IR light. The solvent should be completely dissolved. Example, ethyl alcohol, methyl alcohol and hexane. Detectors. The light signal is converted into electrical signal. Example, photovoltaic cell and photoconductive cell and thermocouples, etc. The amplifier or recorder. The electrical signal is amplified and recorded in wave number. Will be explained by Mahishri.
There are totally 5 applications in IR spectroscopy. So the first application would be identification of functional group. The IR region is divided into two regions. The first will be group region and the next will be fingerprint region. So based on the peaks of the functional group, the name of the functional group can be identified. And the second application would be identification of substances. Organic compounds have many absorption bands, and not all the compounds and many compounds have same absorption band. So based on the absorption bands, we can identify which functional group it is. The third application would be studying the progress of the reaction. Any chemical reaction can be taken and tested. So in that, the rate of the disappearance of the reactant and the rate of the appearance of the product can be identified with this IR spectroscopy. And the fourth would be detection of impurities. Compounds can be identified by variation in the peaks with the compound that is taken as standard. The fifth application is quantitative analysis, and in this the baseline technique is used. So similar to detection of impurities, the peaks of the substances are observed, and the quantity of the organic compound can be determined. And there are certain limitations in this IR spectroscopy. So molecular weight cannot be predicted through this method, and it does not provide information of the relative position of the functional group. Thank you.
We all get the basic knowledge in IR spectroscopy. Thank you all.
Thank you.